Hi, I'm Ms. Benson with SanfordFlipMath, and we're looking at the Algebra 2 Springboard textbook, and we're in Activity 13. This is a review of solving systems of both linear and nonlinear functions using a few different methods. So this is all of Activity 13. So we're going to do one example here to start with our solving by substitution, and we're also going to talk about graphing and solving using a table as well. So as you can see, we have a system of two equations here. One is linear, one is not so much. We have a quadratic equation as well, quadratic function. And we know that this is a system of equations because we have this brace here, right? And when we are trying to solve a system, we are trying to find, so again, we're solving. So what we're trying to find is the value or values that make not one, in this case both, but all, in all cases, equations true. Okay, so we're looking for the values of both x and y that are the same for both of these. Okay, so we're going to start using substitution. Now we talked about this before with linear cases, right? So we were able to solve for one variable and plug that function, that whatever we solved for, into the other variable in the other equation. Well, luckily here we already have that done. So both are set equal to y. So I'm going to plug this part that's set equal to y in for this y. So I'm basically just setting my equations, setting my functions equal to each other. Okay, so I've got my 2x squared minus 3x plus 6 equals negative 2x plus 9. All right, now I got rid of my y by substituting in for it. So in order to get what I need next, remember, I'm trying to find the value or values that make all equations true. Now, I need both x and y in order for that to happen. So I don't have a y, but I can solve for my x. So I'm going to do that by first putting it in standard form, because we know quite a few ways to solve once we do have it in standard form. Okay, so I'm adding 2x to both sides in order to, whoops, I don't want to make a mistake there here. Okay, I'm adding 2x to both sides and subtracting 9 from both sides in order to get one side equal to 0. Okay, now I've got a couple different ways I can use to solve this for x, right? We've done, so that's our goal here, solve for x. So one method would be factoring. Another is completing the square. That's the CTS, is completing the square. And our third method is our quadratic formula. Okay, now I'm going to try factoring just because it seems to go more quickly when I use factoring if it's possible. If it doesn't work, then we'll use another method. Okay, so here we've got, in order to factor, we've got to take a times c. So we've got 2 times negative 3 in that case. That equals our negative 6. And I'm going to take factors of that add up to negative 1. Okay, so I've got, since that has a negative sign, I want my bigger factors to be negative. So 6 and 1 are factors, negative 3 and 2 are factors. This one adds up to negative 5, this one adds up to my negative 1. So those are it. Now we're going to put things in boxes here. Okay, so I've got, this is just more practice with factoring here. 2x squared, we've got our negative 3 in here, and then we want our negative 3x and 2x. Okay, now in order to find my factors, I find common here is 2x, common here is negative 3, common across, we've got x and 1 down there. Okay, so I can write my factors as 2x minus 3 and x plus 1 times the quantity of x plus 1 equals 0. Okay, now in order to solve for x, using my zero product property, I can set each of these factors equal to 0. And at any one time, any one of these is going to be true. Okay? So that means my x can equal, once I add 3 to both sides, we've got 2x equals 3, so x equals 3/2 once I divide by 2. And here I'm just going to subtract 1 from both sides to get x equals -1. So at any one time, x can be either my 3/2 or my -1. Okay, so when we're trying to find my solutions again, we're finding value or values that make these true. Well, both of these are true when x equals either of those two numbers, okay? So I'm going to start making a table now that I have some values here, okay? So I'm going to draw just a little something here to keep things organized. So I've got my x's, my y's, okay? Now I'm going to put my 3/2 in one color and my -1 in another color, because now my y is going to depend on whatever my x is, okay? So I have my x, since it makes both of these equations true, way back up here, I can plug my x into either one of these, okay, in order to solve for y. And both of them are solved for y. Plug x into either of them. I'm going to choose to plug my x into this one here, just because it's linear. I only have one x to worry about instead of 2, right? I don't have to deal with an x squared or any other sign errors there, okay? So I'm going to use my y equals -2x plus 9, okay? -2x plus 9. So I'm going to find my y value when x equals 3/2, okay? So we've got multiply -2 times 3/2. Our 2's cancel out here. So we've got -3 plus 9, y equals 6, okay? Now I'm going to do the same thing. So y equals 6 when x equals 3/2. So I'm going to organize it like that, okay? Also, I've got to figure out what my y equals when x equals -1. Okay, so I've got, again, my y equals -2x plus 9. Y equals -2 times -1 plus 9. So y equals 2 plus 9, y equals 11. Okay, so y equals 11, again up here, when x equals, whoops, that's positive 11. It's not set up, okay? Positive 11 when x equals -1, okay? So I'm going to write these as ordered pairs, these two solutions. So this one goes together, that's why they're in the same color, and this one goes together, okay? So my two solutions are 3/2, 6, and -1, 11, okay? So by solving by substitution, those are the 2 points I get. Now, to connect it to our solving by graphing, since I get two solutions here solving by substitution, I know that I should get 2 points on my graph where the graphs of the functions intersect. And those are going to give me those same solutions, or they should anyways. So I'm going to go over here to my graphing calculator, my handy dandy graphing calculator. I already have the two functions plugged in. So now we're going to graph them and see what they look like. Okay. So, well, I can only see one intersection. It looks like it could be somewhere around this 1/2 here, maybe, perhaps. But you know what? I'm not going to try and worry about that right now. I want to make sure that I can see all of it. So I'm going to set my x Okay, so I'm setting my window here to, I'm just changing my y-axis because I couldn't see the top part of my graph. So I'm going to set the minimum down to 0 because nothing was down around 0, but I'm also going to change my maximum to something more like 20. And we'll see if we can see everything there. Okay. There we go. Now we have 2 points that are intersecting on our lovely graph here. So first of all, how do we find our solutions of a system by graphing? What are we looking for? Well, we're trying to find, again, the solutions that, or the value or values that make both of the equations true, both of the functions true, which means that they have to have points on that intersect, okay? Because since our graphs are pictures of the solutions, these pictures intersect at these points. The pictures are the same at those 2 points, which means that those are both the values that make both of the solutions, or both of the equations true. I keep saying solutions. It's not, do not write that on your test if you have that. All right. So we've got 2 points here. How do we find out exactly what they are? I mean, we can give a good guess that this one is at, we've got a, this one's close to our -1, and we expect it to be at -111. We've got 2, 4, 6, 8, 10, 11. Somewhere around here. That's probably 11. Okay. So this is probably our -1, 11. This must be our 3/2, 6. That would work. Okay. But let's make sure that we get those exactly using our calculator, because I'm sure that you will want to know how to do that, how to check your information. Okay. So what I'm going to do is go to my second, oops, I'm holding the marker. That makes an issue. Okay. All right. So second calc. Okay. So now I want to find out where these functions intersect, where the graphs intersect. So I'm going to go exactly where you want to go, to the intersect. Okay. And I'm going to hit enter. Get there. Now you want to go close to where they intersect. This one's asking, is it on the first graph? Yes. Enter. Is it on the second one? It shows up here that it's at my -2x plus 9. All right. Yep, it's there. Okay. Yep, we've got it. I'm going to hit enter. A guess. Now it wants you to put the pointer right around where you think they intersect. That looks pretty darn close. So I'm going to hit enter again. This gives us, this point here is at -1, 11. That's exactly what we found out when we solved the system using substitution. You're one of the solutions, right? Okay, so let's find out about this other one over here. Okay, we've got another intersection as well. So I'm going to do the same process. I'm going to do my second calc. That's the blue above the trace button. Go down to number 5. All right, hit enter. Now this time I want to get closer by the other intersection point. Okay, still on my first curve, so I'm going to hit enter. I'm on my second curve, or the line. All right, and then am I as close as I can be? Probably somewhere around there. And I'm going to hit enter and see what it gives me. So this one tells me I'm at, the other intersection point is at 1.56. Let's flip over here. We got 3/2 6, which is the same as 1.56, and again, our -111. So this is just another method of solving our systems of equations. We found the value or values that make both of the equations true by finding out where the two graphs intersect. Okay? Now, one other method that we want you to be able to know about solving systems is how you solve them using a table. Okay, so I already have my graphs plugged in. Okay, so I'm going to clear the ink from up here, and we're going to go to the table. Now, the table is very clearly here. It's a blue table, so I need to hit my second key, and I need to hit my, I'll erase my ink, graph in order to get to my table. Okay. Now, where were our x values around? Where do we need to be in order for us to find out whether where our points of or where our solutions are. Okay, so the first x value, we're in the negatives, so let's go down to see if around -1, that was the x value for the other two methods. Aha! So when we get to x equals -1, we've got -1 is our x value, and then both y1 and y2, or y1 was our quadratic function, y2 was our linear function, both those equal 11 at x at -1. Okay, that's exactly what we're looking for, because the value of x equals -1 makes both of these true at the same point. Okay. All right. Now we're going to look at see if we have if we can find the other value here. Okay. So that one was at about 3/2, right? So that would be about 1.5. Okay, well, we don't have 1.5 on our table here, but we do have 1 and 2, so I'm going to circle both of these. Okay, so we see that here, these are kind of trading, our two values here are trading places. So this one's equal to 5, and it goes up to 8. Well, then this one is equal to 7, and it goes down to 5. Okay, so it's like right at somewhere in between here, something about the graphs is changing. Something's different. Okay, and that's where our solution falls into place. If you're asked to do this on a test for us, you won't have to find solutions based on whether it's based on something like this. You're going to see the tables match, but you should know that if you look here and you kind of come in between those two values, 1 and 2, you're going to find that value of, now 6 would fit in the middle of 5 and 8, right? And 6 would fit in the middle of 7 and 5 too. Okay, just like we've got 1.5 is in the middle of 1 and 2. Okay, so it makes sense that we can solve our system by using the table here. Okay? So just to recap, we're going to look at we're going to find the solutions of a system by both using a table, using graphing, and also by substitution. We've done all three here. Okay? Now I'm going to do another example of solving using substitution. Okay, so this one is going to be, I'm not going to do it all three ways just because it gets a little bit nastier. Okay, but in this case, just bear with me. I'm going to walk through a few more steps, show you another, we've done a lot of solving for x by factoring, so this will give you another idea. Okay, so we've got, again, we want to solve by substitution. So this one, this function here is set equal to y. I can plug all of that into the other y. Okay, so it gives me -4x squared plus 5x minus 8 equals -3x minus 24. Okay, again, I need to get to something, a quadratic expression is equal to 0, because that'll give me a way. I know whole 1, 2, 3 ways to solve our solution using a once we have a quadratic equation set equal to 0. Okay, so I'm going to add 3x to this side, add 3x to this side, add 24 to this side, and to this side as well. Okay, so that gives me -4x squared plus 8x plus 16. That's equal to 0. Okay, now is this one going to factor? Well, first of all, I'm going to see if there's a common factor in all of my terms here. And it just so happens that there is, okay? I can divide all three terms by -4, in order to make this a little bit simpler. Okay, so if I divide this one by negative 4, I get x squared, negative 2x, and negative 4. That's still equal to 0 because 0 divided by any number is equal to 0. Okay, now I'm going to look and see, can I factor here? And I already told you that we couldn't, but factors of 4 that add up to negative 2. I've got a negative 4 and 1. That'll give me negative 3. Nope. Negative 2 and 2, that gives me 0. So nope, neither of those work. So I'm going to go to using the quadratic formula to solve for my x. Okay, so you don't have to use factoring in order to solve for your x value here. You can use any of the methods that you're comfortable with. If you don't want to worry about factoring because you're never sure if you're going to get it right or not, and you want to jump to the quadratic formula, go right ahead. Just be careful about what you're plugging in and make sure that you don't lose your negative signs like here. So my negative b is negative 2, right? And then I have my plus or minus the square root of, I've got my negative 2 squared minus 4 times my a is 1, right? 1 times my c, which is negative 4. Okay, ooh, that's an interesting yellow. Okay, so I'm going to rewrite that in black here. Negative 4, okay? All right, so and that's all over my 2 times 1. All right, so since I'm setting this all equal to this quadratic formula, I have to be really careful when I'm calculating, right? So the opposite of a negative 2 makes this plus. So I have a positive 2 plus or minus the square root of 4 minus 4 times negative 4. So that also becomes, I have 2 negatives. I'm multiplying a negative times a negative, so I get a positive. 4 plus 16 all over 2. All right, back up here. Okay, then we get 2 plus or minus square root of 20 over 2. Now I can rewrite this because 20 has a factor that's a perfect square. That's my 4. So I need to simplify this as much as possible. Okay, I can't leave it as a square root of 20 because there is a simpler way to write that. I can go even further, okay? So I've got my 2 plus or minus 2 because that is the square root of 4 times the square root of 5, okay? And then all of this was over 2, so I'm going to divide both parts by 2 because by having this whole thing over 2, that means I'm dividing this by 2 and I'm dividing this part by 2, okay? So I have it set in both places. Once I divide by 2, this one ends up being 1. 2 divided by 2 is 1, plus or minus 2 times the square root of 5 divided by 2 gives me the square root of 5. So x equals 1 plus the square root of 5. Okay. Whew. Took me a little bit longer than the last time, but I got 2 values for x. I can have my 2 solutions for x because remember, this plus or minus means that I have x equals 1 plus the square root of 5 and or x equals 1 minus the square root of 5. Okay, so at any one time it can be one or the other. Okay, so now I'm not quite done. All right, I have to, so I'm gonna just do a table to organize this stuff again. Just make sure that I keep everything straight, which one's which. Okay, so I have my x's and y's. My 1x is 1 plus the square root of 5. My other x is 1 minus the square root of 5. But no matter what, I still have to solve for my y value. And it may not be as easy or as clean as the other one, but we can still do it. So just like before, we're going to plug our values into one of these 2 equations, this one or this one. Again, especially since I have a little bit messier x values, I'm going to plug it into the linear equation just because it's going to make things a whole lot more simple. Okay, so my linear function is y equals negative 3x minus 24. Okay, so I'm going to plug each of my x values into this. So I'm going to do this one, start with that one. Okay, so I have y equals negative 3 times 1 plus the square root of 5 minus 24. That gives me, when I distribute, I get negative 3 minus 3 times the square root of 5, still minus 24. Now, I can't combine the term that has the square root in it, but I can combine the terms that are alike. So these two, okay, so I have my negative 3 minus 24, that gives me a negative 27 minus 3 square roots of 5. Okay, so that gives me one of my lovely y values. Okay, so this one can go up here. We've got my negative 27 minus 3 square root of 5. Okay, now I'm going to do the same thing for the other value. Okay, so I've got this lovely linear function. My y equals negative 3x minus 24. Okay, now the only thing that's changing is my sign. So I have 1 minus the square root of 5 now instead. Okay, so I've got 1 minus square root of 5 minus 24. Okay, distribute all the same. So I've got negative 3 plus, whoops, forgot my 3 in there, plus 3, here, let's erase that and rewrite it just to be clear, minus 24. Okay, so this one, I get a negative 27 plus 3 square roots of 5 equals my y value. So this is my y value that matches this one here. So this one is negative 27 plus 3 square roots of 5. So I only changed this. So for each of these, only the sign changed. But I don't want to be done. I need to write them both as coordinates, okay? Because even if they look a little bit funky, they can still be written as x and y coordinates, okay? So in this case, x plus the square root of 5 is my x value, and negative 27 minus 3 square roots of 5 is my y. And the other one is here. We've got 1 minus the square root of 5 and negative 27 plus 3 root 5. Okay, so this one was a little bit messier, but we still found two values that make this system true. Okay, because both of those values make both of these equations true. Okay, so thank you for watching Sanford Flip Math. I hope this has given you a good review of solving systems, so when we have linear and nonlinear functions in the same system. And thanks for watching. Come see us again. Bye.